Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we're going to be continuing our unit on absolute value functions and reciprocal functions. We're still looking at absolute value equations. Remember, we've been dealing with solving them algebraically and using our case-by-case analysis to determine what x will be when it's greater than or equal to 0 or less than 0. Let's get started on today's lesson. We're going to be looking at this example, which is an absolute value equation with no solution. So I think you probably know what's coming, but let's just solve algebraically and see what's about to happen. So our first step is always going to be to isolate our absolute value expression. So let's go ahead and do that. So we have the absolute value of 3x minus 4 is going to be equal to, now we want to subtract this 12 out from both sides to get this absolute value expression isolated. So 9 minus 12 is negative 3. All right, now let's just look at this for a second. We really don't have to do any more steps. All of this is inside an absolute value expression. So no matter what variable we put in here, what's going to be true? This is always going to be positive. It's inside an absolute value expression. Well, can a positive number be equal to a negative number? No, it cannot. It's as simple as that. So if you have on one side an absolute value expression, no matter what it is, by itself, and that should be equal to a negative number, it's not going to happen. It's just not possible. So our answer here is no solution. Now, just to make sure that you believe me, let's work it out. Okay, if we have absolute value of 3x minus 4, there's two cases, right? There's 3x minus 4 is equal to negative 3, and negative 3x minus 4 is equal to negative 3. So this is 3x minus 4 equals negative 3. 3x equals 1, negative 3 plus 4. X equals 1/3. Here we have negative 3x plus 4 equals negative 3. Then we have negative 3x equals negative 7. And we have x equals 7/3. Okay, if we test our solutions, which I think just to speed things up, we're just going to plug it into our calculator here. Let's get rid of this stuff. Plug it into our calculator here. So we have 3 times 1/3 and minus 4. That's what's inside our absolute value expression. That's negative 3 plus 12. Well, first remember that negative 3 is inside the absolute value sign, so it's going to become positive. So you're going to have positive 3 plus 12 is equal to 15. And of course, 15 does not equal 9. No. Okay, let's try the next one. So we have 3 times 7/3 minus 4, which is 3. The absolute value of 3 is 3. So that's going to be 3 plus 12, which is, again, 15. And 15 equals 9? No, 15 does not equal 9. So, no solution. Now, I proved it. You don't have to do this. Please don't do this. Use your logic that says that if you have an expression inside an absolute value sign, this has to be positive. And a positive number cannot equal a negative number. It's simple as that, okay? It's your turn. Remember, I may be tricking you. You need to check your answers, okay? Don't work out the full solution. Just get to the point where you can logically say if there will be a solution or not. Do your work, pause the video, and come back when you have the solution. I'll see you soon. All right, welcome back. We have the solution ready for you. Let's go ahead and take a look. So the first thing that you would have done is isolate your rational expression. So you're going to have the absolute value of 4x minus 5 is going to be equal to negative 7. Well, it can't, right? Because this is going to be positive and this is going to be negative, so they won't be equal. No solution on this one. On the right-hand side, when you isolate your expression, it's the same thing. You have a positive expression here and a negative one over here. They will never be equal. So no solution. Last problem of the day is an absolute value equation involving a linear and a quadratic expression. So this, don't worry, it's the same. You know, isolate your absolute value expression, do your two cases. Let's make that smaller. Do your two cases here. So you're going to have x minus 10 equals x squared minus 10x, and you're going to have negative x minus 10 equals x squared minus 10x. Solve. So x minus 10 equals x squared minus 10x. Let's move everything to this side. So we're going to subtract x plus 10. So you're going to have x squared minus 11x plus 10. This is factorable, thank goodness. This is x minus 10 and then x minus 1, which means x equals 10 and x equals 1. And we can check that in a minute. Let's do this side. So we have negative x plus 10 equals x squared minus 10x. Let's add x and subtract 10 from both sides. So now we're going to have 0, because these all cancel out, equals x squared. This is going to be minus 9x minus 10. Is this factorable? Yes. X minus 10, x plus 1. All right, so x equals 10 and x equals negative 1. Notice that these are the same, so we're only going to have to check that once. Let's check it. If I plug in 10 here, 10 minus 10 is 0. So this becomes 0. Plug in 10 here. This is going to be 100 minus 100 is 0. Does 0 equal 0? Yep. Both of these work. It was a little bit quick, so I was able to do it in my head. Now we have 1 minus 10, so this is negative 9. So this is going to be positive 9. Let's try this side. We're going to have 1 minus 10, which is negative 9. Is 9 going to be equal to negative 9? No. So that's not going to work. What about this one? We're going to have negative 1 minus 10, which is negative 11. So this is going to be positive 11. Let's try this side. Negative 1 squared is 1. And then negative 10 times negative 1 is plus 10. Is 11 going to be equal to 11? Yes. So that one works. So we had one extraneous solution. 3 of them worked. All right. It's your turn. Last problems of the day. Go ahead and just pause the video, work them out, and come back when you return. Okay, welcome back. Let's go through the solution. So first thing that you would do is separate them into your two cases. On the left-hand side here, you're going to get to this point and realize you can't factor it. So you probably either use the quadratic expression or completing the square, and you would have found 1 plus root 5 over 2 and 1 minus root 5 over 2. Now in the calculator here, you can see the first step. Let's go up to the equation. The first step was to put in your first value of x, square it, and subtract 1, and you find this, which if you look closely, this has the same denominator, so it's 1 plus root 5 over 2. Now that's going to be the left-hand side, right? And it's going to be positive. What's on the right-hand side? Just x, and what was x? 1 plus root 5 over 2. So of course, 1 plus root 5 over 2 equals 1 plus root 5 over 2. So this is a solution. Let's check the next one, 1 minus root 5 over 2. So when you plug it into your formula here, you get this. Now I had my suspicions, so I converted it to a decimal, and I saw indeed it is negative. So what's going to happen is that's what's in here, and it's going to become positive. So what we need to know then is, now that it's a positive number, what is this when it's by itself? And that was the next thing I tried. I put in 1 minus root 5 over 2, and then I made that a decimal, and it's also the same number, but negative. So what happened here is a little bit unfortunate, where we have this being negative, except it's in absolute value signs. So this is a negative value in absolute value signs, which makes it positive. And then this is going to be a positive number. And of course, a negative number. And of course, they're not going to be equal with one another, because a positive number cannot equal a negative number. So that's it for that one. Let's try the next one. Again, you're going to split it up into its two cases. Okay. This one, you're going to simplify down. You get this nice looking quadratic, which thank goodness is factorable. And you get x equals 5 and x equals 4. Now, I did these in the calculator as well. So with x equals 5, on the right-hand side, you got 0. And of course, if I put 5 on the left-hand side, 5 minus 5 is 0. Absolute value of 0 is 0. And of course, 0 equals 0. So it works. Do the same thing with the 4 this time, and you get negative 1 on the right-hand side. And of course, this has to be positive, and it's going to equal positive 1, and 1 does not equal negative 1. On this side, you're going to simplify into this nice quadratic, which again, luckily is factorable. It's always nice when it is. And you get x equals 5, x equals 2. Well, we already tested x equals 5. You don't have to do it again. 0 equals 0. So that works. Just test the 2, and you'll see the right-hand side is equal to 3. And when you plug the 2 in here, 2 minus 5 is negative 3. Absolute value of negative 3 is 3. And that's it for today. Hope you got the right solutions. See you next time for our next lesson on reciprocal functions. Bye-bye. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end. And over here, you will find the next video in this unit. Keep learning, everybody. Take care.